Hi, I'm Alan Ross. We're here at the RE Plus Conference and Exposition. We're talking to thought leaders about the future of the energy economy. So join us and enjoy. My next guest is Larry Zulch. He is the CEO and founder?
Just CEO.
Just CEO of Infinity Energy Systems. Did I get it right?
You got it right.
Thank you so much. Thank you for joining me, Larry.
Thank you for having me.
So we're going to talk a lot about the company, but just tell me how you got involved in Infinity, and that's a great name, by the way. It's almost infinity, but not
almost,
quite.
but with a V for, in our case, vanadium, which we'll talk about later. Infinity was created out of the merger of two companies.
Okay.
I was the CEO of one of them, Avalon Battery, which was really a Western North America company. We were doing a lot of science in Vancouver, and then we did a lot of commercial activities in California. And we merged with a company, Red T Energy Systems, in the UK. And so we became a public company, and that was in 2020.
And you can hear the entire audience clapping for the fact that it became a company. But and so Infinity right now is global then, because you got London offices, you got Vancouver. Battery technology, which we're going to talk a lot about, is really important to decarbonization.
That's right.
I mean, wind and solar doesn't work if we can't store it, right?
Right.
So what I'd really like, the integration of what, because you're typically, we talk about batteries, we're talking about lithium ion, or we're talking about lead acid, right?
Yes.
You used a word, vanadium?
Vanadium.
Vanadium. It's one of the elements.
It is, element 23.
Okay. And you made a battery system out of vanadium. Tell me about that.
Well, you know, that it was actually discovered decades ago that vanadium could be used to store electricity. And a company, Sumitomo of Japan, was one of the pioneers and has made some pretty good sized battery systems using vanadium flow technology. But our company productized it, made it into a product, built in a factory, ready to go.
Okay, you said flow batteries. It is a flow battery system?
It is a flow battery.
I was at a conference and somebody said the future is flow batteries, so here it is.
I couldn't agree more. The future is flow.
Flow, yeah. And talk about that and why vanadium batteries are better than whatever else we have out there.
So, first of all, you step back and you say energy storage is so critical to the transition to renewable energy. As you say, when the wind is not blowing and the sun's not shining, and you still want electricity, you have to have stored it.
Right.
And in the past, that was mainly done with water pumped uphill. But now, that's not always applicable. California, we know, doesn't have enough water to do that. And many places don't have enough hill.
Yeah.
So storing it chemically makes sense.
Yeah.
Well, of course, when you're looking for energy storage, you think lithium batteries.
Right.
They're compact. We see them everywhere in cars and cell phones, et cetera, et cetera. But they're not the perfect solution for big stationary energy storage. They have a tendency sometimes to have what they call thermal runaway.
Right.
We would call it catching fire. And they also tend to wear out. We've all had an old cell phone or something where it doesn't hold the charge anymore.
Right.
They're still very, very impressive for many purposes. But is there a better alternative? That's what we're developing, is the alternative, and it is called a flow battery because the energy is stored in tanks of liquid electrolyte.
Okay. And it is utility scale. This is not residential scale.
The disadvantage of our battery, and it never catches fire, it never wears out, and it'll never be in a car. It'll never be in a truck. It's not as energy dense as a lithium battery. So, you put lithium batteries in close proximity to each other, and one catches fire, it can propagate. So you separate them. Yeah. So per acre, our battery actually stores as much energy per acre as lithium batteries.
Are they in containers or
they are container sized? They are containers. That's great because they're big and heavy, and we take advantage of the global shipping apparatus, that can handle containers. So we ship them all over the world. We have the largest flow battery in the UK. We're putting in the largest flow battery in Australia. We're putting in the largest flow battery in North America, in Canada. And we've got more coming along.
So when you start getting those up and running, case studies, I'd love some case studies about,
absolutely.
Okay, what is the result of putting in utility scale? Because if we don't do utility scale, we will never decarbonize.
That's exactly right. Right.
Yeah.
No, we have to have utility scale energy storage.
So I want you to step away from batteries for a minute.
Yes.
and talk to me as a subject matter expert on this whole green energy revolution. The war in Ukraine, the bills that were passed in Congress, there's just so much energy. We're at the RE Plus conference. There's so much energy around this whole thing. But talk about what your perspective is, the challenges that we face in renewable, not just in battery storage.
Yeah. No, I mean, if you take it from the very broadest view, the widest view, we have been using stored solar energy forever. That's what we call it's what's in the ground, and we call it oil and gas. It's solar energy that is stored in carbon. And how do we get it out? Heat. So we have been heat-based. Heat first, electricity second. You use the heat to make electricity, wherever that is. That's how it's been forever. We're now going through this major shift to electricity first. This show is full of solar panels that don't make heat, they make electricity. Wind turbines, electricity, not heat. So we're moving the world from heat first to electricity first. That transition is critical, and it means that the thing that came along with heat first energy, carbon being emitted, no longer is necessary, and that's going to help us out a lot. So you say that's fantastic. The problem with electricity first is if you don't store it, you can't depend on it.
Right.
So that means the transition to electricity has so many different areas where we're going to be electrifying things, because you don't have to go through a heat cycle. You can go straight into heat pumps, electric cars. You can go straight into using electricity even in industrial processes. But when you need heat, you turn the electricity into heat. And that's through the hydrogen cycle. Our batteries power electrolyzers up in the Scottish Islands, so we can talk about that, and hydrogen electrolyzers.
I was born in Edinburgh, so I really want to know that case. Okay.
Well, actually, one of our primary facilities is right outside Edinburgh in a town called Bathgate.
Yeah.
I was there just about a week ago.
Yeah.
So, making that heat out of electricity when you need it to make steel or concrete, cement, then we're electricity first, heat second. That transition is just an enormous transition, but it gives us the potential for greater quality of life and less climate change.
So it sounds like it's a DC revolution, because it really is. If you think about it, we have an AC system that creates the whole heat to electricity, and so if you create DC power, wind and solar, and you don't have to convert it, you go right into the car to drive the car to work. It's a fascinating.
We're the system that we're putting into Australia, the biggest flow battery in Australia, is connected with a very large solar system. And the problem sort of is a great example of South Australia, which is where Tesla put in their first grid scale system. South Australia, when the sun's shining, they actually are giving away electricity. Sometimes they're even paying users of electricity to take it. They have so much. And then hours later, when the sun goes down, their cost goes way up as people can't get the electricity they need. So putting in a big solar farm in Australia requires energy storage.
Right.
Well, in the past, you convert that solar energy into AC and then store it back into DC again. In our system here, working with SMA, who's exhibiting here, a big inverter manufacturer, the power goes straight in DC from the solar straight into the battery, and then is only turned into AC when it needs to power the grid. So it's much more efficient. We save substantial amounts of energy that way.
So talk about the future. You're kind of in a now moment, okay?
Yes.
What do you think the future looks like for renewables, for decarbonization, and how quickly do we get there?
The future is an ongoing process of more and more electrification, but it's going to be marked by bumps up and down. If you talk to the California Energy Commission, they'll say, we're a little concerned about the stability of the grid when we get high percentages of renewable energy. California just went through a milestone of over 100% of its energy was renewable for the first time. But
I think that was only 6 minutes, though.
I think it was. I said for a moment. I mean, I should qualify. Yes, it was a very short time. Still a milestone. It could occur. But nonetheless, grid instability. We're going to see that. But what we're really going to be affected by is major lithium shortages. lithium
right
battery
now,
storage. I think it's unacknowledged the extent to which that's going to occur. And we need them for in EV mobility, for other electrifying so many parts of the world. So we feel like we're doing our part by creating an alternative chemistry to lithium, commercializing it, making it available. Every time you put in a vanadium flow battery, you're not only getting the benefits of a battery that doesn't catch fire, doesn't wear out, but also